All right, so in 401, we got introduced to trig. We talked about conversion from degrees to radians, radians to degrees, finding coterminal angles, finding complements and supplements in both radians and degrees. And then we finished it with the arc measurement. So number 1 says find 2 coterminal angles, 1 positive and 1 negative, and the degrees 120 degrees. So to find coterminal, what do we do if it's in degrees? Add 360 or subtract 360, right? So if I add 360, here I get 480. That's a positive angle. That's 1 coterminal angle, a positive one. And then 120 minus 360 is negative 240. And there's my negative coterminal angle. So it's angles that, if I graph those, they should look exactly the same as the 120 minus how many times they go around. Number 2 says find the A complement and B supplement of the angle, and it gives you pi over 3. This time it's in radians, so if I want to find the complement, what do I do?
Subtract the angle from pi over 2 for the complement.
Good.
And for the supplement, we'll subtract the angle from pi.
Good. So in radians, for the complement, I'm subtracting from pi over 2 because that's 90 degrees. And for the supplement, I'm subtracting from pi because that's 180. And we said if this is negative, then there is none of those. So you kind of want to look and see if 1/3 pi is bigger than 1/2 pi. And it's not, so I'm going to continue. If it was bigger than 1/2 pi, I would say there's no complement. And if it was bigger than pi, I would say there's no supplement. So from here, I want to change these so they have the like denominator, which is 6. This would be 3 pi over 6. This would be 2 pi over 6. And 3 pi over 6 minus 2 pi over 6 is what? Pi over 6. That's your complement. And then pi minus pi over 3 becomes 3 pi over 3 minus pi over 3, or 2 pi over 3. That's your supplement. Good on those? Questions? Okay, 3 says convert the angle to radian measure. So remember, it could just say convert from degrees to radians, radians to degrees, or it could just say, or vice versa. You've got to be able to look at it and say if it's radians or degrees. And remember yesterday we said the only way to know for sure is that the degrees has to have the degree on it. Radians typically has pi, but does not have to have pi. But the degree has to have the degree. So when we're converting, we're multiplying the degree by what? Pi over 180. So the zeros are going to cancel, and then 3 goes into both 15 and 18. 15 5 times, 18 6 times. So this is 5 pi over 6. You want to keep these answers exact. You don't want to use a calculator. You don't want to use a decimal. And then the last thing is a circle has a radius of 7 inches. Find the length of the arc intercepted by the central angle of 210 degrees. So we said the equation for the arc length is S equals theta times R, but what is true about theta? Has to be in radians. So this 210, I first have to convert 210 times pi over 180. Again, cancel through the zeros. And again, 3 goes into these, 7, 6. So that's 7 pi over 6 times 7, or 49 pi over 6. This time they gave you a unit, it's inches. So I'll use it on my answer. And again, quiz, you'll keep that in terms of pi. Even test, you'll keep it in terms of pi. You'll keep it exact just like it is. You won't use the calculator to find it. Good? Questions? Okay, now we're going to talk unit circles. So I'm going to teach you how to walk through filling in every little blank on this circle. If you know another way or you're more comfortable, totally do it. I'm just going to share with you what I think works for me. On the iTunes U course, there's even videos from former students have done different tricks. Feel free to use those. However, it gets you to fill in every single blank on this unit circle. So this will be your next quiz. It's going to look exactly like this piece of paper, except it's going to say name at the top. That's the only difference, okay? And you're going to fill in every little blank that's on there, okay? So first thing I'm going to fill in is the angles, because that's the thing we're the most comfortable with, in degrees, right? So yesterday we talked about the quadrant angles, where this was 0, this is 90, this is 180, this was 270, and this is 360. So those are the quadrant angles. You would know what line to put them because they have the little degree symbol. Everybody with me so far? Yeah. All right, then the pattern for the angles in degrees is to add 30, 15, 15, 30 in every quadrant. So 30, 15, 15, 30 first quadrant, 30, 15, 15, 30 second, 30, 15, 15, 30 third, and then 30, 15, 15, 30 fourth. So if I take 0 and I add 30 to it, I get 30. Add 15 to 30, you get 45. Add 15 to 45, you get 60. Add 30 to it, and you're at the top on 90. Then I go to the next one. So 30 would be that 90 at the top. You know, you're in the right spot, and then repeat that process. So 90 plus 30 is 120. Plus 15, 135. Plus 15, 140. And then 30 brings me to the 180. So those are your checkpoints. 150. I'm on a roll, folks. 150. I was just checking to see if you're paying attention. Good job. Next one is, again, 30, which means 210, 15, 225, 15, 240, 30, 270. Last quadrant, same pattern. 270 plus 30 is 300. Plus 15, 315. Plus 15, 330. Plus 30 brings you to 360. So again, if you fill in the 4 quadrants that you're supposed to know the quadrantal angles, then it helps you with that pattern. Okay, you're 1/3 the way there almost. There's a couple other things, but not far off. Now we're going to do the radians. So I could sit here and convert every single one of those into radians by multiplying by pi over 180, and you'd still be here until tomorrow because you'd be doing so much stupid stuff, right? So better to have it memorized. You won't have that long for your quiz. If you need to check it every once in a while, that's one thing, but you don't want to learn how to do it that way. So do the same 4 quadrant angles like we talked about yesterday. This would be 0 radians. At the top is what? Pi over 2. On the left, pi. On the bottom, 3 pi over 2. And we'd finish it back at the front, 2 pi. So at least get your quadrant angles in there. Then every angle that is closest to your x-axis. So if I'm on the x-axis and I go up or down, the first one you hit is an over 6. So I would do pi over 6, and then eventually we're going to come back and change some of these. But every single one of those starts with pi over 6. So closest to the x-axis is pi over 6. Closest to the y-axis is pi over 3. And then the in-between is pi over 4. So it should make sense that closest is over 6 because 6 is the biggest denominator. If I divide something by 6, it's going to be smaller than if I divide it by 4 or 3. So closest is 6, closest to the x is 6, closest to y is 3, and the in-between is 4. In the first quadrant, those numerators stay as they are. So it is pi over 6. Pi over 6 is the same thing as 30 degrees. Pi over 4 is 45. Pi over 3 is 60. In the second quadrant, we're in between a half pi and pi. Our numerator is 1 less than the denominator. So I want it to be a little bit smaller than 1, if you think about it that way, right? Because 1 pi is at the 180 spot. So this is 2 pi over 3, 3 pi over 4, and 5 pi over 6. Numerator is 1 less than denominator. In the third quadrant, it's bigger than 1, but less than 1.5. So it is 1 bigger than my denominator. This is 7 pi over 6, 5 pi over 4, and 4 pi over 3. And in the fourth quadrant, these are in between 1.5 pi and 2 pi. It is 1 less than double the bottom. But if you just memorize 5, 7, 11, it's even easier. So it's 1 less than double, or 5, 7, 11.
What was it? Can you repeat like the tricks for each one?
Yep, so first quadrant stays as pi in the numerator. Second quadrant, the numerator is 1 less than the bottom because we need it to be smaller than 1. Third quadrant is 1 more than the denominator because we now need it to be bigger than 1. fourth quadrant is 1 less than double, because double would be 2. 1 less than that, or 5, 7, 11, if you memorize that pattern. So now all the points are going to be filled in, okay? But what I want you to know, more than where they are around the circle, is, because this will help you so much as we move forward, is every over 3, once it's simplified, okay, every over 3 has the point that is 1/2 and root 3 over 2. Every over 4 has root 2 over 2 and root 2 over 2. And every over 6 has root 3 over 2 and 1/2. The only thing that changes is the positive or negative signs. Why that helps you, if I give you something like 73 pi over 6, you should be able to tell me it's over 6, which means it's the bottom coordinates, and then all you have to do is figure out what quadrant that lies in to apply the signs, positive or negative signs. So I'm going to fill them all in. So all the over 6s are root 3 over 2 and 1/2. All the over 4s are root 2 over 2 and root 2 over 2. And all the over 3s are 1/2 and root 3 over 2, the reverse of the over 6. All right, so now let's talk positive and negative signs. In my first quadrant of the x and y coordinates, what's positive, what's negative? In the first quadrant. They're both positive. X and y are both positive, so I'm going to leave all of those the way that they are. In the second quadrant, what's true? Good. X is negative, y is positive, so I'm going to come in here and put a negative on all my x's. In the third quadrant, what's positive, what's negative? They're both negative. And in the fourth quadrant, good. X is positive, y is negative. And then the only 4 things we have left blank are probably the easiest things we could fill in. If I'm going to the right one, this is a unit circle. Unit circle means the radius is 1. So I'm going to the right 1, I'm going left 1, I'm going up 1, I'm going down 1. What would be the coordinate at 0? 1, 0. At 90? 0, 1. At 180? Negative 1, 0. And at 270? 0, negative 1. So that's part of it. Just filling in the unit circle, right? Just knowing what is there is half the battle. Then we got to know how to use it. So the whole section is called unit circle. We're going to learn how to take that circle that we just filled in and apply it, okay? So it starts with the picture of what we just created, right? All of this is based on a circle with a radius of 1. So the equation of that circle would be x squared plus y squared equals 1. And then you would have filled in all the information that we just saw here. Okay, but then we got to figure out how to apply it. So this comes from the length of the arc, the intercept. This is just the where it's derived for all of those points. Okay, if you've got the same unit circle that we started with yesterday, where the radius is 1, all of these positions around my circle are based on the same thing. So if this is 1 and I draw this and that's 60 degrees, then all of the points we just filled in are based on my special right triangle, 30, 60, 90 triangle. If it was at 45, then it would be the same thing. Because I can move that circle anywhere around, or move that point anywhere around my circle, I can make triangles in all 4 quadrants. So I could also enclose it here and say that this is a triangle, instead I'm moving forward, which means a positive x, I'm moving down, which means a negative y. And that's why this point will have a positive x and a negative y. So you can use these little triangles, like I said, as you go around, or stick to the unit circle, use the points that I just gave you. But it's all derived from that arc length. All right, so 6 trig functions. 3 you should be very familiar with, sine, cosine, and tangent. And then there are reciprocal functions, which are cosecant, secant, and cotangent. The sine, in terms of your x, y coordinate, the sine is your y. So sine is your y, cosine is your x. Think c comes before s, x comes before y. The tangent is y over x, where x is not 0, because then it would be undefined. Sometimes tangent is undefined. And then the reciprocal function of sine is cosecant, and that would be 1 over y, or just take your sine and flip it. The reciprocal of cosine is secant. That would be 1 over x, or take your secant, your cosine and flip it. And then the reciprocal of tangent is cotangent, which would be y over x over y, or take your tangent and flip it. So think that the 2s is never, that's people will confuse secant and cosecant. The s's never stick together and the c's never stick together. So the cotangent and tangent should be easy, but cosecant goes with sine and secant goes with cosine. So now, as you moved around your circle, right, in each of those spots, you got a point. You should be able to immediately tell me what's the sine, what's the cosine. It might take you a minute to figure out the tangent because you've got to put y over x, but the sines and cosines should be quick memorization. Every over 6 is going to be the same, right? Every over 3 is going to be the same. Every over 4 is going to be the same. You just got to figure out the sign, the positive, negative sign. All right, so if I gave you this point, we're going to baby step our way into it. Use the figure at the right to find the trig functions at t. So if I gave you this point, which was 1/2 and root 3 over 6, you want to be able to find the sine of t, the cosine of t, the tangent of t, the cosecant of t, the secant of t, and the cotangent of t. So if my point is 1/2 and root 3 over 2, what's the sine? Root 3 over 2. What's the cosine? 1/2. The tangent, I have to do root 3 over 2 divided by 1/2. Keep, change, flip, and I get root 3. With me so far? Okay, cosecant, I'm going to flip sine. So 2 over root 3. Can you leave a square root in the bottom? No, so we got to rationalize this. We're going to multiply both the top and the bottom by root 3. And I get 2 root 3 over 3. Flip the 1/2 and I get 2. With cotangent, you can either do x over y, so I could put 1/2 over root 3 over 2, and then keep, change, flip, times 2 over root 3. I get 1 over root 3, which has to get rationalized, and I get root 3 over 3. Or I could have taken my tangent, which is root 3 over 1, flipped it, and rationalized it. Either way, you have to do it. So sine, root 3 over 2, cosine, 1/2, tangent, root 3, cosecant, 2 root 3 over 3, secant, 2, and cotangent, root 3 over 3. Questions so far? All right, now it says find the point on the unit circle that corresponds to the angle. So instead of giving you the point, you got to find it. It's 2 pi over 3, right? So think, again, recall, what is every over 3? What's the coordinate point at every over 3? 1/2. And root 3 over 2. Now, if you have your unit circle sitting in front of you, you would know that 2 pi over 3 would be the one in the second quadrant, right? Because it's one less than the bottom. But if you don't, you just have to say, what quadrant is that at? 2/3 is in between a half and 1, right? And in between a half and 1 is your second quadrant. And in my second quadrant, the x is negative, the y is positive. Good so far? All right, so now take it a step further. Knowing that angle and the point at that angle, figure out the sine, the cosine, and the tangent. So we already got that 2 pi over 3 would be negative 1/2 and root 3 over 2. What's the sine of this angle? Root 3 over 2. What's the cosine? God bless you. Negative 1/2. And then the tangent would be y over x. Keep, change, flip. And it's a negative root 3. Good so far? Okay, so look, we're not going to go all the way through them, but look at B. Okay, now my angle's negative. It's still in over 3, which means I'm still using the same points, 1/2 and root 3 over 2. Where does a negative pi over 3 live? In the fourth quadrant. Remember we said yesterday there's 2 ways to do it. Either move clockwise, that 1/3 would be less than a half, so you know it's in that first quadrant if you're moving clockwise. Or graph it as though it is positive pi over 3, and then fold your graph in half, and where it overlaps would be the negative. So it's here, which means my x is positive, but my y is negative. So the point would be 1/2 and root 3 over 2, negative root 3 over 2. So in comparison with A, the sine is still root 3 over 2, but it's negative. The cosine would be a positive 1/2, and tangent is still going to be a negative root 3 because it's the same y over x, and one's positive, one's negative. So sine, root 3 over 2, negative root 3 over 2. Cosine, positive 1/2, tangent, negative root 3. Now look at C, 6 pi over 3. Do I say that's over 3 so that the point is 1/2 and root 3 over 2? No, it's different that time.
It's 2 pi.
Good. You can reduce this. You got to make sure you can't reduce it first, right? So 6 pi over 3 is the same thing as 2 pi. What's the point at 2 pi? 1, 0. So my sine is 0, my cosine is 1, and my tangent would be 0 over 1, which is 0. Questions? Everybody good so far? All right, domain and range of sine and cosine. So the domain of the sine function and the cosine function is the set of all real numbers. Domain goes left, right, positive, negative, fractions, decimals, all the way around, okay? It's all real numbers. The range of these functions is the set of all real numbers from -1 to 1 inclusive. So domain can change, but range will never get bigger than 1 or less than 1. Because if you think about what's happening as you move around your circle, as I go around this circle, wait for it. My y's are never going to get bigger than 1 or less than -1. And sine and cosine are periodic, which means that the functions behave in a repetitive or cyclic manner, and the period for each is 2 pi. That means that we now know all the points that are on my first circle, but I can continue around and around and around this circle, and you should still be able to figure out those same points. So if I give you something like 13 pi, that's not on my initial unit circle, but I know that if 2 pi and 0 are on my right, that every 2 pi is going to continue to be on my right. Does that make sense? So all my even whole numbers are going to continue to be on the right-hand side. 2 pi, 4 pi, 6 pi, 10 pi, 32 pi, 148 pi would still be on the right-hand side and still give me the point of 1, 0. All my odd whole numbers are going to be on the left side of my graph. So whether it be pi or 13 pi or 101 pi, I would know that the point that coordinates goes with it is negative 1, 0. Does that make sense? So if, and it's going to happen, your angles are going to get bigger than 2 pi. You're going to convert them into mixed number. You're going to figure out where they fall. They're going to be at sum over 3 over 4 over 6 or one of these quadrant angles. And then from there, you'd figure out your point, and from there, you'd figure out your trig functions. So it's not only going to live in your unit circle. And especially if I'm giving you back your unit circle to use, it's not going to be on that paper. It's not going to be like a reference sheet. All right, so knowing that, it says evaluate the trig function using its period as an aid, meaning it's not going to be on your normal unit circle. Figure out where it would be. So these are just one. Pay attention. It doesn't say all 6 trig functions. It's one trig function. A says the sine of 13 pi over 6. So 13 over 6 is not on your unit circle. 13 over 6 would be what in mixed number form? 2, yeah. 2 and 1 6 pi, or 2 and pi over 6. Yep. Everybody understand that? Yeah. So 2 pi is on what side of my unit circle? Left side or right side? Right side. I'm pretending I already went around it once, right? And then I have to go 1/6 more than that. So I'm going to stop at the next over 6, which is pi over 6. And you know the point there is root 3 over 2 and 1/2, which means the sine is what? 1/2. Cosine of 5 pi. So where is the odd whole numbers? On the left. This could be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Either way, I'm stopping on the left. And the point there is negative 1, 0, which means my cosine is what? Negative 1. So even whole numbers on the right, odd whole numbers on the left. And then from there, you have to ask yourself, am I going less than 1/2 more or bigger than 1/2 more? From there, you can determine which quadrant you're in. Okay, even and odd functions. So we've talked about this in terms of graphs, but we're going to talk about it in terms of trig functions now. The cosine and the secant functions are even, which means if I give you the positive angle or the negative angle of cosine and ask you for cosine or secant, they stay the same. They don't change. And think about why that happens. What coordinate is cosine? X or Y? X, right? So if I were to say, what's the cosine of pi over 6? All right, so what would be the coordinate point, or what would be the cosine at pi over 6? Square root of 3 over 2, right? And then what if I said negative pi over 6? What would be the coordinate at negative pi over 6, or the cosine? Also root 3 over 2 over 2, right? So it doesn't matter if I use the positive angle or the negative angle for cosine. The positive negative doesn't change. Same thing would happen over here if I was doing 5 pi over 6 or negative 5 pi over 6. Both those cosines are going to be negative. And because you use cosine to get secant, the same thing's going to happen. So if I asked you for the cosine of positive pi over 2 and the cosine of negative pi over 2, they're going to be the same. The signs won't change. That is just for cosine and secant. Everything else changes. So if I asked you for the sine at pi over 6, you would have told me it's positive 1/2. And if I asked you for the sine at negative pi over 6, it would be negative 1/2. If I asked you for tangent of pi over 6, you would tell me it's root 3 over 3. And if I asked you for the tangent at negative pi over 6, it would be negative root 3 over 3. So cosine and secant are the only ones where the sign does not change if the sign on the angle changes. Everything else changes. Okay, we talked about these already. If I have one, I can switch it with the other. So sine is 1 over cosecant, but cosecant is also 1 over sine. Cosine is 1 over secant. which means secant is 1 over cosine, and tangent is 1 over cotangent. Cotangent is 1 over tangent. So they're interchangeable, and when we get to verifying trig identities, you're going to get a bunch of different identities. These are called the fundamental ones. All right, use the value of the trig function to evaluate the indicated functions. So A is giving you that cosine of t is negative 1/3. When these values are not on your unit circle, this is when you can draw yourself a triangle, okay? So if I'm missing a side, I use the Pythagorean theorem. But these are direct relations of the other ones, right? Cosine and secant are reciprocals of each other. So I don't need a third side. I can just flip these. So if I have cosine of t is negative 1/3, what would be cosine of negative t? Negative 1/3, right? Remember that cosine doesn't change signs. So it's still negative 1/3, and then the reciprocal of that would be negative 3. So cosine and secant are even, they don't change. But sine and cosecant, these would change, right? So if the sine of negative t is 3/5, what's the sine of positive t? Negative 3/5. The sign changes. And then the cosecant of t is the reciprocal of sine of t, which would be negative 5/3. So if it gives you 1 and the sign changes on the angle, okay, last thing is easiest because the calculator does the work for you. There is a trick, however, and you have to be careful. This is now when the mode of your calculator is important. Once we hit the trig button, we have to be in the right mode. So you have to look at these questions and say, am I in degrees or am I in radians? And then you have to go to your calculator and match that mode. So in the calculator, let me get to... Okay, on your calculator under the mode button, you should see on the very 4th line, you see radian and degree. These are in radians, so I'm going to leave it as it is. If they were in degrees, I'd switch it, okay? But I need it to be in radians, so I'm good to go. Then I'm going to look at what it says. It says secant of 4.5. Look on your calculator. Do you see a secant button? No, because it's not there. What trig functions do you have? Sine, cosine, and tangent, right? You don't have the reciprocal functions. So I have to say that secant would be the same thing as 1 over the cosine of 4.5, and then that's how you type it in. So 1 divided by the cosine of 4.5, making sure you're in radians, and that's negative 4.7439, so 744. Cosecant would be 1 over the sine of 0.9, 1 divided by sine 0.9, and you get 1.276, so 277. And then tangent, you actually have that one, so tangent pi divided by 2. And look what it says. What happens at tangent of pi over 2? This is 0, 1, right? So y over x would give you what? Undefined. Your calculator will actually help you. And then cotangent, last one would be 1 divided by tangent, negative 1.2. So quit this. 1 divided by tangent, negative 1.2. And I get 0.3887, so negative 3.389.